Hello, welcome to Student Tools. In this video, we will be doing a Mathematics Paper 1 revision of November 2015, which means it's the final exam paper. In this case, it's for the grade 11 class of 2015. So if you're in grade 11 or 12 and you would like to gain experience on how to find solutions on exam-like questions, this video has been made for you. As you might know, with paper 1, we have a bit of algebra with question 1 where we solve equations and inequalities. We also have sequences or number patterns. We have graphs, parabolas and hyperbolas. We have probability, and lastly we have financial mathematics. So without any waste of time, let us start our revision. Question 1, 1.1, we are supposed to solve for x. 1.1.1, we have x squared plus x minus 12 equal to 0. So how do we solve for x in this case? We factorize. So when we factorize, we use brackets. In this case, we'll have two brackets which will be equal to 0. On the first bracket, we'll have an x here and an x here on the second bracket as well. The next thing we'll do is find two factors of 12 which when multiplied together they will give us an answer of negative 12 but give us an answer of positive 1 when we add them together. So let us list the factors of 12. We have 1 and 12. We have 2 and 6. We have 3 and 4. So these are the factors of 12. So we have to use two factors of 12 which when multiplied together they will give us an answer of negative 12 but give us a positive 1 when they're added together. I think this pair can work for us because if we make this 3 a negative, it will give us an answer of negative 12 when we multiply and give us an answer of positive 1 when we add. So the next thing we'll do is take the negative 3 as it is and take the positive 4 as it is and put it there. So now we have x minus 3 multiplied by x plus 4. So now we have factorized. So the next thing we'll do is write x minus 3 as it is equal to 0. Or with x plus 4 here equal to 0. Then on this side we have to take the negative 3 on the left hand side to the right hand side. And how do we do that? We add the 3 and on the right hand side as well. So we'll have x is equal to 3. Or on this side as well, to take the positive 4 from the left hand side to the right hand side, we will have to subtract it here and subtract it here as well, such that we have x is equal to negative 4. So now we have solved our x. X is equal to negative 3 or x is equal to negative 4. Alright, let us move on to 1.1.2. Here we have root 2x plus 1 equal to x minus 1. In this case, we're also supposed to solve for x. So how do we solve for x? We have this root. We cannot just solve for x while having this root, so we have to get rid of it. How do we get rid of that root? We square it. So if we will square the left hand side, we also supposed to square the right hand side. Then the square will cancel the root, such that we'll have 2x here plus 1 equal to x minus 1 squared. Now let us expand these brackets. X minus 1 squared is the same as x minus 1 multiplied by x minus 1. Let us write this as it is, 2x plus 1. Let us expand the brackets of x minus 1 times x minus 1. X times x is x squared. X times negative 1 is equal to negative x. Negative 1 times x is equal to negative x as well. Negative 1 times negative 1 is positive, because a negative multiplied by a negative will give us a positive answer. So it is a positive 1. Let us write this as it is, 2x plus 1, because there's nothing changing on this side. Here we have to collect the like terms. So we have x squared minus x is equal to negative 2x plus 1. This is equal to 2x plus 1. There's still nothing changing this side. So now we have to take whatever is on this side to the other side. So how will we take this to the other side? We're supposed to subtract 2x. We subtract 2x and we subtract it on this side as well. We have to take the positive 1 by subtracting it too. So we'll have minus 1 here as well. So this will give us x squared negative 2x minus 2x is equal to negative 4x. This will cancel. So which means we have x squared is equal to 0. Let us take it to the side. We have x squared minus 4x is equal to 0. Since we have this now, let us factorize it. What is the common factor in these terms? We have x as the common factor. So let us factor out x and introduce our bracket. To get x squared, we have to multiply x with an x. And here we have a negative sign. So to get 4x, we have to multiply x with a 4. Close our bracket, and this is equal to 0. So now x is equal to 0. This x, or x minus 4, which is in this bracket, is equal to 0. Well, since we're not done here, we have to take this negative 4 to the right hand side. We add it and add it here on the right hand side as well, which makes it x is equal to 4. So we have two answers. We have x is equal to 0 or x is equal to 4. Now we are done with 1.1.2. Let us do 1.1.3. 1.1.3, we have 2 to the power x root x equal to 2 to the power 27. So when we have exponents with the same basis and trying to solve for x, we can use their indexes and solve for x. So now we will have x root x equal to 27. Now let us solve for x in this case. X root x is the same as x to the power 1 multiplied by x to the power 1 over 2 equal to 27. Now with exponents, when we multiply terms with the same basis, we add their indexes. So in this case, we'll have x to the power 1 plus 1 over 2. So what is 1 plus 1 over 2? 1 plus 1 over 2 is equal to 3 over 2. This is all equal to 27. Now let us make 27 to the base 3. So what is 27 to the base 3? It is 3 to the power 3. This is equal to x to the power 3 over 2. Now we want to get rid of this 3 over 2. So how do we do that? We'll multiply 3 over 2 with its reciprocal. The reciprocal of 3 over 2 is 2 over 3. So if we will multiply with 2 over 3 on this side, we also have to multiply with 2 over 3 on the right hand side as well. So this will cancel this and this will cancel this. So which means x is equal to the power 1 now. So we will make it x. And on this side we'll have 3 to the power 3 times 2 is equal to 6 over 3. 6 over 3 is equal to 2. So this makes it 3 to the power 2. Now x is equal to 9. (1.1.4) we have a quadratic inequality. We are still solving for x. So we have a quadratic inequality of x squared minus 2x minus 8 is less than 0. So this is our quadratic inequality. Solving quadratic inequalities is just the same as solving normal quadratics. That is why our next step will be to factorize this. And when we factorize quadratics, we use two brackets. We will have an x here and an x here as well. Next, we will have to find factors of 8. So what are the factors of 8? We have 1 and 8, 2 and 4. Do we have more? No, I don't think we have more factors of 8. So which of these factors can we use and get an answer of negative 8 when we multiply and get negative 2 when we add? I think we can use this pair when this 4 is negative. Why? Because 2 multiplied by negative 4 is equal to negative 8, and 2 plus negative 4 is equal to negative 2, which is the coefficient of this minus 2x. And then here we will have plus 2 and a minus 4 here. So now we have factorized our quadratic. What's next? If x plus 2 was equal to 0, x will be equal to negative 2. Or if x minus 4 was equal to 0, x will be equal to a positive 4. Now that we have these x values, which are x-intercepts of the quadratic graph, let us plot them so that we can see the structure of the graph and also get to see where the graph is less than 0. Now let us draw our axis. So this is our x and y axis, and we'll have negative 2 here plus 4 here, or a positive 4. With these x values, which are the x-intercepts of the quadratic graph, let us draw the structure of the graph. So this is our graph, and we want to find where x is less than 0. 0 is the x-axis, so x is less than 0 here. So from here to that part. So that is why we will describe our quadratic inequality as x should be greater than -2, which is this one, but less than 4, because it's this part. And that is how we solve quadratic inequalities. 1.2, given f of x is equal to 5x squared plus 6x minus 7. 1.2.1, so for x, if f of x is equal to 0, and our answer is supposed to be correct to 2 decimal places. So we're given f of x equal to 5x squared plus 6x minus 7. And with 1.2.1, we're supposed to solve for x if f of x is equal to 0. So if f of x is equal to 0, which means 5x squared plus 6x minus 7 equal to 0. So we're supposed to solve for x here. Now how do we do that? We factorize. So how do we factorize in this case? We multiply the leading term with the constant. So here we have 5 and 7. When you multiply 5 and 7, you get an answer of 35. So with 35, we have to find factors of 35, which we can add together and get an answer of positive 6, which is the coefficient of this x. So now let us find the factors of 35. The first pair will have 1 and 35, which is obvious, and the second one will have 5 and 7. Do we have more? No, we do not have more. So which means these are the pairs we are allowed to use. Are there any of these terms that we can use together and get an answer of of positive 6 when they're added together? It seems like there are no factors that we can use to get positive 6 when we are adding them together. So that means this trinomial cannot be factorized. So what do we do when a trinomial cannot be factorized? We use a quadratic formula. The quadratic formula is x equal to minus b plus or minus root b squared minus 4ac all over 2a. So here is our quadratic formula. So where do we get the a, or the b, or the c? So with the trinomial that you're given, this one, the leading term is 5x squared, which means we'll use the coefficient of the leading term, which is 5, as a, and use the next term's coefficient, which is 6, as b, and the constant is c in this case. So that is how we substitute in the quadratic formula. Now let us substitute into our quadratic formula. So x is equal to minus b. b is the coefficient of this x. So the coefficient in this case is 6, a positive 6. So which means we'll put it in brackets. And 6, which is positive, and the negative is outside the bracket. So plus or minus root b squared. B is the coefficient of x, which is 6, and here we'll put it in brackets. 6, b is what? Is squared, so we'll also square the 6, minus 4ac. Okay, we have 4. What is a? A is the coefficient of x squared, which is 5. So we'll substitute 5. And c is 7. But here we have to look at the sign as well. So the sign here is -7. So we'll substitute -7. All these is over 2a. 2 with a, we have to substitute a, the coefficient of x squared, which is 5. Now we are done substituting. So we have to sort this out now. X is equal to, this is -6 plus or minus. Let us sort whatever is under the root. 6 squared is equal to 36 minus 4 multiplied by 5 is 20 multiplied by -7, that is -140. So we will have -140. So 36 minus -140, which makes this a plus, which means it's 36 plus 140. That gives us 176. We'll put it under the root. So all this is over 2 times 5 is 10. So now we have x is equal to -6 plus or minus root 176 all over 10. So let us punch these in our calculators and see what answers can we get. So go and punch in your calculator. -6 plus, we will first use the plus and later we'll get to use the minus. So now we'll say -6 plus root 176 over 10. Let us use brackets. So we have -6 plus the square root of 176, close your bracket. All this divided by 10. We get an answer of 0.726. And on your question paper, we're supposed to give an answer which is correct to 2 decimal places. So we'll have to round this up to 0.73. So that means our x is equal to 0.73. Or remember that the first time we used a plus, now we'll use a minus. So this is what we'll do. Let us go back to our calculator. Introduce your brackets if you're using a calculator like mine. -6 minus the square root of 176, close your bracket, all this divided by 10. So now we get an answer of -1.926664. Yeah, and we are supposed to give it to 2 decimal places, so our answer is supposed to be -1.93. That means x is equal to -1.93. So now you have solved for x. 1.22. Hence or otherwise calculate the value of d for which 5x squared plus 6x minus d is equal to 0 is equal roots. So we have 5x squared plus 6x minus d equal to 0. So we're supposed to calculate the value of d if 5x squared plus 6x minus d has equal roots. So how do we calculate the value of d if the trinomial has equal roots? Let us use our quadratic formula to calculate the value of d. X is equal to minus b plus or minus root b squared minus 4ac all over 2a. This is a, this is b, and this is c. So let us substitute. X is equal to minus b is 6 plus or minus root b squared is 6 squared minus 4a is the coefficient of the leading term, which is 5, and c, which is represented by d, negative d in this case, so we have negative d. All this over 2a, which is 2 times 5. Okay. So in this case, we're told that this trinomial has equal roots. So when a trinomial has equal roots, its b squared minus 4ac is always equal to 0. So the b squared minus 4ac is equal to 0. Our b squared minus 4ac is represented by 6 squared minus 4 times 5 times negative d. So in this case, this is supposed to be equal to 0 because this represents the b squared minus 4ac. So this is what we will do to show that it has equal roots. 6 squared minus 4 multiplied by 5 multiplied by negative d. All this is supposed to be equal to 0. So we want to find the value of d, right? So 6 squared is equal to 36 minus 4 times 5 is equal to 20. 20 multiplied by negative d is equal to negative 20d. All this is equal to 0. Now let us solve for d. Let me take this to the top. So which means we have 36 plus 20d equal to 0. This is because two negative signs give us a plus. So that is why we have 36 plus 20d equal to 0. So now let us solve for d. We'll take the 36 to the other side by subtracting 36 here and subtracting 36 here. So we'll have 20d equal to negative 36. Divide by 20. Divide by 20 here as well. This cancels. And negative 36 divided by 4 is 9. Negative 39. 20 divided by 4 is 5, of which our answer is negative 9 over 5. Sorry, over 5. So our d is equal to negative 9 over 5. And now we're done. Since now we're done with 1.22, let's do 1.3. 1.3, we have a simultaneous equation. We are supposed to solve for x and y. So let us write the two equations that we have. We have x minus 2y equal to -3, and we also have x y equal to 20. So this is equation 1, this is equation 2. So in this case we will use the substitution method, but before we use the substitution method, we will take equation 1 and make x the subject of the formula so that we can substitute on equation 2, which is xy equal to 20. So let us make x the subject of the formula with equation 1. So equation 1 is x minus 2y equal to -3. So if we want to make x the subject of the formula, we will take this 2y to the right hand side. And how do we do that? We add it, plus 2y and plus 2y on this side as well, which means this side it will cancel, such that we'll have x equal to -3 plus 2y. So now x is the subject of the formula. Next, we have equation 2, which is x y equal to 20. So now that we have this, for x we'll substitute -3 plus 2y. So we will put it in brackets. We'll have -3 plus 2y, and then take the y as it is, equal to 20. So y multiplied by -3 is -3y. Y multiplied by 2y, we have plus 2y squared equal to 20. So let us rearrange this, and we will take the 20 from the right hand side to the left hand side. How do we do that? We will subtract it from this side and then subtract it here as well. So we will have -20 or -20 equal to 0. So now we have 2y squared minus 3y minus 20 equal to 0. So now what's left is we have to factorize this so that we can get the values of y. So how do we factorize this? This is what we will do. We will multiply the coefficient of the leading term and the constant. So we will multiply 2 and 20. 2 multiplied by 20 is 40. Now what do we do with the 40? We have to find factors of 40, which when multiplied together, they will give us an answer of 40. But when we add them, they have to give us an answer of -3, which is the coefficient of -3y. So let us list the factors of 40. First we have 1 and 40, which is obvious. We have 2 and 20. We have 4 and 10. We also have 5 and 8. Do we have more factors of 40? No, I don't think we do. So let us see which of these pair of factors can we use to get an answer of -3 when we add them together. I think we can use this pair of 5 and 8. when we have the 8 as negative, so that when you add negative 8 and 5, you will get an answer of negative 3, which is the coefficient of this y. I want us to rewrite our equation using this pair of vectors. So we'll write 2y squared, but with the negative 3y, we'll distribute using these two factors. So we will have negative 8y plus 5y, because negative 8 plus 5, you get negative 3y, which is the same thing, but we just distributed these two factors to get negative 3y. So let us finish up with the negative 20. We'll bring it down, negative 20 equal to 0. Now here is what we will do. We will factor out the common factor between the first two and the last two factors. So what is the common factor within the first two factors? We have 2y as the common factor. So let us factor out 2y. 2y, then introduce our bracket. To get 2y squared, we have to multiply 2y with y. Then let us move on to negative 8y. In order to get negative 8y, what do we have to do? We have to multiply 2y with minus 4. So 2y multiplied by minus 4, we get minus 8y. Then we close our bracket. Now we have to find the common factor between the last two terms. The common factor between 5y and minus 20, it is 5. So let us factor out 5. So plus 5. And then we factor out. And then we introduce our bracket, So in order to get 5y, we have to multiply 5 with a y. And to get 20, we have to multiply 5 with a minus 4 to get minus 20 as well. So we close our bracket, equal to 0. Now, since we have done that, we have to finish up our factorization. So the first thing we will do, we will take the factors that we will take the terms that we have factored out, which is 2y and plus 5, put it in one bracket. So 2y plus 5, and close our bracket, which is this and this. So now we have y minus 4 and y minus 4 here. We'll put it in one bracket as y minus 4 equal to 0. Now we have factorized. So you must notice that we were factorizing this in this case in order to get the value of y. Now I will rewrite this at the top. So it is 2y plus 5 in brackets and y minus 4 in brackets equal to 0. So the next thing we will do, since we want to find the values of y, we'll write 2y plus 5 is equal to 0, or y minus 4 is equal to 0. So here we have to take the 5 to the other side, which is the right hand side. And how do we do that? We subtract 5 and subtract 5 here as well, such that we will have 2y is equal to negative 5. And then we divide by 2 and divide by 2 here as well, which cancels this. So we'll have y equal to negative 5 over 2. And here as well, we have to take the -4 from the left hand side to the right hand side by adding it. +4 and +4 here as well. So this will cancel. We will have y equal to +4. So that means we have two values of y now. We have y is equal to -5/2 or y equal to +4. So since we have two y values, we also have to get two x values because we still haven't found our x. So we can use any of these equations, equation 1 or equation 2, to get the value of x when y is this or when y is that. So let us do that now using equation 1 or equation 2, but I will choose to use equation 2. So now we have our y values. We have to find the x values now when y is equal to -5/2 or when y is equal to 4. So we will use equation 2 to get our x values. Equation 2 is xy equal to 20. First we will substitute when y is equal to -5/2. So x multiplied by -5/2 equal to 20. Notice that instead of y, we substituted -5/2. So that means when we multiply x in this fraction, we will have -5x/2 equal to 20. So in order to get rid of this fraction, we have to multiply by 2 on the left hand side and multiply by 2 on the right hand side. So this will cancel this, such that we will have -5x equal to 20 times 2 is equal to 40. So we divide by -5 this side, divide by -5 here as well, such that this will cancel this. And then we'll have x equal to 40 divided by -5 is equal to -8. So when y is equal to -5/2, x is equal to -8. We can even write this. Next, we will use equation 2 and substitute for when y is equal to 4. So let us do that. So equation 2 is xy equal to 20. Now let us substitute for y. X multiplied by 4 equal to 20. So we have 4x equal to 20. Now we divide by 4 on both sides to get rid of the 4. This will cancel this, and x is equal to 20 divided by 4 is 5. So now we have x is equal to 5. So we can put it here. X is equal to 5. So when x is equal to 5, y is equal to 4. And if you have done that as we have, you will get 6 full marks as stipulated on the question paper. Now let us move on to question 2. Question 2. 2.1. Simplify without using a calculator. Two point one, we have 2 to the power n plus 2 multiplied by 4 to the power n plus 1, all these over 8 to the power n minus 1. Now let us expand this with 2 to the power n plus 1. So when we have a plus here, it means we have 2 multiplied by 2 to the power 2. So we have 2 to the power n multiplied by 2 to the power 2, because when they have the same basis, we add the indices. So that is why 2 to the power n plus 2 is the same as 2 to the power n multiplied by 2 to the power 2. In this case as well, we will have 4 to the power n multiplied by 4 to the power 1, but we don't have to write a 1 because with 4 is just to the power 1. So all this is over 8 to the power n multiplied by 8 to the power negative 1. See, it's the same thing as what we were doing on the top. Now let us continue. Now what we want to do is make everything to the base 2. So this is already on base 2, so we'll write it as it is. So 2 to the power n multiplied by 2 to the power 2. We just want to make this to the base 2. So multiplied by 4 is the same as 2 to the power 2. And all this is to the power n, because this is 4n. And 2 to the power 2 is 4, 4 to the power n. So let us continue. Multiplied by 2 to the power 2, because this is 4. 2 to the power 2 is equal to 4. And all this is over. Now we want to make 8 to the base of 2. 8 as base 2 is 2 to the power 3. So 2 to the power 3 is 8. And all this is to the power. And all this is multiplied by. Here we have 8 as well. We want to make it base 2. 2 to the power 3. All this is to the power what? Negative 1. So now let us continue simplifying this. We'll take it to the other side. So we have 2 to the power n here, 2 to the power n, and 2 to the power 2. We multiply to the power 2. Now we have this. Let's just put our multiplication sign here. So now we have 2 to the power 2 to the power n. So when we have something like this, we just multiply the indexes such that we will have this as 2 to the power 2n. We just multiplied the indexes, and then we multiply by 2 to the power 2, which is this one. All this is over. We have 2 to the power 3 to the power n. In this case, we also multiply the indices and place the same base. So we have 2 to the power 3 times n is 3n multiplied by 2 to the power 3 to the power negative 1. Here we also multiply the indices. We multiply 3 and negative 1. 3 multiplied by negative 1 is negative 3. So we will have 2 to the power negative 3. Now we have made everything to the base 2. 2 to the power n multiplied by 2 to the power 2n is the same as adding their indices. So we will have 2n plus 2n is 3n. So all this is multiplied by 2 to the power 2 multiplied by 2 to the power 2. So we'll add the indices 2 and 2. 2 plus 2 is 4. So we'll have 2 to the power 4. All this is over 2 to the power 3n multiplied by 2 to the power negative 3. So now this is multiplication, which means we can divide this. We'll cancel that. So now we have 2 to the power 4 over 2 to the power negative 3. Now we have to divide this, and they have the same basis. But before we do that, I want you to note what we did when we were multiplying 2 to the power n and 2 to the power 2n. So when you multiply, we added the indices. So what do we do when we divide? We subtract. So what is 4 minus negative 3, which is this one? 4 minus negative 3, a minus and a minus will change to a plus. This. So we will have 4 plus 3. It is equal to 7. So which means the index what we'll have is 7. So it is 2 to the power 7. So what is 2 to the power 7? 2 to the power 7 is equal to 128. So now this is our final answer. 2.1.2, we have something like this. Root x plus, let me extend my root 2x minus 1 multiplied by root x minus root 2x minus 1. So we have to simplify this. This is the same as root x plus root 2x minus 1 multiplied by x minus root 2x minus 1. Let us put some brackets because there is addition and multiplication, so it will be easy for us to understand this. So now let us simplify this. This is the same as root. Now this multiplied by this is x squared. X multiplied by negative root 2x minus 1. So we will have a negative sign here because it's a positive multiplied by a negative. So we'll have a minus, and let us put this in brackets just so it is x multiplied by this, which is x multiplied by root 2x minus 1, close bracket. Now we multiply root 2x minus 1 multiplied by x. So we will have a positive sign here. And let us put it in bracket. So it's this multiplied by that. So it's x root 2x minus 1, close bracket. So the last part is the square root of 2x minus 1 multiplied by the square root of 2x minus 1. It is the same as the root of 2x minus 1 squared. So the square will cancel the root. So now we will be left with 2x minus 1. So here we are multiplying a positive and a negative, so which means our sign will be negative. And we'll put the 2x minus 1 in brackets. So now we have something like this. We have x squared. This will cancel this, such that we will be left with minus bracket 2x minus 1. So this multiplied by that is minus 2x. That multiplied by that is plus 1. So now we are left with root x squared minus 2x plus 1. So what's next? Let us factorize this. We have root, and we will use two brackets. So we will have x here and then x here. What are the factors of 1? What are the factors of 1 that we can add together and give us an answer of negative 2? Factors of 1, we have 1 and 1. In order for it to give us negative 2 when we add together and give us a positive 1 when we multiply, they both have to be negative. So that means it's x minus 1 multiplied by x minus 1. That is the same as root x minus 1 squared. So this root will cancel the square. That means we are left with x minus 1. So this is our final answer. 2.2. We're given that p is equal to the root of 5 over x plus 2 plus x over 3. So the question with 2.2.1 says, for what values of x will p be a real number? With fractions, we cannot divide with a 0. So whatever we get here, it has to be greater than 0. The square root of a negative number is undefined, and any number divided by a 0 is undefined. So in this case, with the denominator, it has to be greater than 0, so that we will not get a 0 or any number less than 0. Because if we get a number less than 0 with the denominator, that means we have to find the square root of a negative number or negative fraction. So with that, we won't get a real number. And if we get a 0 with the denominator, with whatever value we substitute for x, and we get a 0, that will still give us an undefined fraction. So in this case, you just have to take the denominator part, which is x plus 2. This part has to be greater than 0. Therefore, we take the 2 from the left hand side to the right hand side by subtracting minus 2 here as well. So whatever you do on the left hand side, you have to do it on the right hand side. Therefore, we are left with x should be greater than negative 2. So all the values of x should be greater than negative 2, so that p will be a real number. Okay, next we have 2.2.2. Show that p is rational if x is equal to 3. So this is just easy. We just have to substitute 3 wherever there is an x. So let us substitute. So we have something like this. P is equal to root 5 over x plus 2 plus x over 3. Now we substitute root 5 over, now we have an x, we substitute with a 3, 3 plus 2 plus 3, we substitute with a 3 wherever there's an x, over 3. So that means this is root 5 over 5 plus 3 over 3 is the same as 1. So now we have something like this. 5 over 5 is the same as 1, which is the root of 1 plus 1. The root of 1 is 1, which is the same as 1 plus 1, which is equal to 2. Now we have showed that P is rational because we got an answer of 2. Now we have 2.3. Calculate the sum of the digits of 2 to the power 2015 multiplied by 5 to the power 2019. So it is something like this: 2 to the power 2015 multiplied by 5 to the power 2019. In this case, we cannot use a calculator. But one thing you should note with the question is that we should calculate the sum of the digits of the answer we will get here. Let us first try to get the answer. So let us try this. 2 to the power 2015 multiplied by 5 to the power 2015 multiplied by 5 to the power 4. Okay, what you must note here is that 5 to the power 2019 is the same as 5 to the power 2015 multiplied by 5 to the power 4, because with the same basis, we just add the indices. 2015 plus 4 is equal to 2019. What I wanted to do is to make the 5 and the 2 to the same index, so that we will do this: 2 multiplied by 5, all this to the power 2015, and then let us bring down the 5 to the power 4. Now this is the same as 10 to the power 2015 multiplied by 5 to the power 4. 5 to the power 4 is equal to 625. So now that means we have 625 multiplied by 10 to the power 2015. If you would punch this whole thing on your calculator, you would just get an error, so you cannot calculate it with your calculator. So now when we have something like this, it makes it easier for us, because we know that we will have a 625 and any number multiplied by 10 and with 10 to the power 2015, it means the 10 will have 2015 zeros. So when we multiply 625, it will also have 2015 zeros. Yes. So the question said we should calculate the sum of the digits. So what digits do we have? We have 6, we have 2, and we have 5, and 2015 zeros. So 6 plus 2 plus 5 plus the zeros is equal to 6 plus 2 is equal to 8. 8 plus 5 is equal to 13. So this is our final answer. Question 3. 3.1. Given the linear pattern 5, -2, 9, and -289. So now we're doing sequences. We're given a linear pattern of 5, -2, -9, and -289. 3.1.1, we're supposed to write down the constant first difference. So how do we get the constant first difference? Let us do this. To calculate the constant first difference, we will not use this because it's the last term. So to get the constant difference, we calculate it like this. It is T2 minus T1, or term 2 minus term 1. So which means -2 minus 5. -2 minus 5 is -7. And term 3 minus term 2. So which means here we will have -9 minus -2. -9 minus -2, which is -9 plus 2. So that is -7 as well. So that is how we find the constant difference. So now we know that our constant difference is -7. 3.1.2, write down the value of T4. On the previous question, we found that the pattern has a constant difference of -7. So how does that help us get term number 4? So this is what we will do. Since we have something like this, -7 is the constant difference. And here we will have a -7. So this is T1, T2, T3, and we have to get T4 here. From T1 to T2, we add -7. So it is 5 plus -7. That means it is 5 minus 7, which is equal to -2. From T1 to T2, we add -7. That means from T3 to T4, we also have to add -7, of which we will have something like -9 plus -7, which is the same as -9 minus 7, which is equal to -16. Therefore, our T4 is equal to -16. 3.1.3, calculate the number of terms in the pattern. Our pattern is 5, -2, -9, and with the last term as -289. So we are supposed to calculate the number of terms when the last term is -289. So how do we calculate the number of terms in the pattern? We have to find the equation of the sequence or the pattern. But then how do we find the equation of the pattern? The equation of a linear pattern is determined by T n is equal to a plus bracket n minus 1 times d. So we use this equation to determine the equation of a linear sequence or linear pattern. A represents the first term, D represents the constant first difference. So in this instance, we have to determine our A, which means we have to determine our first term, and determine our D, which is the constant first difference or the common difference. N is the term number. In our pattern, A is equal to, the first term is 5. D is the constant first difference. We determine the constant difference on 3.1.1. It is equal to -7. So let us substitute these to get the equation of the linear sequence or pattern. So now we will have Tn equal to, A is equal to 5. So we will substitute with a 5 here, plus n minus 1 times d is equal to -7. Now let us sort this out. Tn is equal to 5. Now let us multiply this out. -7 multiplied by n, we have -7n. -7 multiplied by -1 is plus, because it's a negative multiplied by a negative, plus 7. So that means we have Tn equal to 5 plus 7 is equal to 12 minus 7n. So this is the equation of our linear pattern. And then we will use this equation to determine the number of terms in the pattern. What we know is the last term is -289. So that means with the equation of the pattern as Tn equal to 12 minus 7n, -289 is the last term, equal to 12 minus 7n. Let us solve for n now. So what we do is we'll take the 12 to the left hand side. So what we do is we'll subtract 12 and subtract 12 on this side as well. This will cancel. -289 minus 12 will have -301 this side, equal to -7n. Now we will divide with -7 on both sides. -7, this will cancel. Now -301 divided by -7, so that means we have 43 equal to n, which is the same as n is equal to 43. Therefore, that means we have 43 terms in the pattern. 3.2. A linear pattern has a difference of 3 between consecutive terms, and its 20th term is equal to 64. That is, T20 is equal to 64. So in this case, we know that it is a linear pattern. So when it is a linear pattern, we know that we will have a constant difference, and in this case the constant difference is equal to 3. But then we're given T20. T20 is equal to 64. 3.2.1, we are supposed to determine the value of T20 22. You see? From T20, which is equal to 64. How do we get T21? How do we get T22? We use our common difference. So that means from T19 we had to add 3, because when you subtract 3 from 64, which is how you get T19, you get 61. So now we also have to add 3. So what is 3 plus 64? That is 67. And to get T22, we also have to add 3. That is 67 plus 3, which makes this 70. Then our T22 is equal to 70. Alright, now we move on to 3.2.2. Which term in the pattern will be equal to 3T5 minus 2? So in this case, in order for us to determine what this question requires us to do, we need to find T5, and in order for us to find T5, we also need to find the equation of the sequence. So let us go back and see what we know about the pattern. First, we're told that it is a linear, and the common difference is equal to 3. T20 is equal to 64. On the previous question, we were required to find T22. T22 is equal to 70. We can also include T21. T21 is equal to 67. So, how do we find the equation of a linear pattern? Tn is equal to A plus bracket n minus 1 multiplied by d. In this case, we already know our d, but we don't know our A. We'll use T20. So here we will have 64 equal to A, which is the unknown, plus n minus 1, which is 20 minus 1. Here we will have 20 minus 1, which gives us 19, multiplied by d, which is 3. Then here we have 64 equal to A plus 20 minus 1 is 19. 19 multiplied by 3, that is 57. Now let us take the 57 from the right hand side to the left hand side. We subtract 57 and subtract 57 this side as well. Now we will be left with A equal to 64 minus 57, that is a 7. Therefore, now we know our A. A is equal to 7. So that means in the standard equation, we can substitute and get the exact equation of the pattern. We will have Tn is equal to A is 7 plus n minus 1 in brackets times d, which is 3. This is Tn is equal to 7, 3 times n, that is plus 3n. 3 times -1, that is -3. Now that is Tn equal to 7 minus 3, that is 4, which means we will have a 4 plus 3n. So now this is the equation of the pattern. So now that we have the equation of the pattern, we can determine 3t5 minus 2. 3t5 minus 2. So 3 multiplied by t5. How do we get t5? t5 is determined by 4 plus 3 multiplied by 5, because it is t5. For n we substitute with 5, then subtract 2. Oh, we forgot to close the bracket here. So now we will sort this out. This is 3, open bracket, 4 plus 3 times 5. 3 times 5 is equal to 15, plus 4, that is 19. So that is 19 minus 2. 3 times 19 is equal to 57 minus 2. That is equal to 55. So now we know what is 3t5 minus 2. But that is not what is asked of us. What we're asked is we have to find which term is equal to this. Then we have to find the term which is equal to 55. Then again we have to use this equation to get which term is equal to 55. This is what we will do. Tn, which is the equation of the pattern, equal to 4 plus 3n. Then 55 is equal to 4 plus 3n. We take the 4 from the right hand side to the left hand side by subtracting here on the right hand side and subtracting on the left hand side as well. This will cancel such that 54 minus 4 is equal to 51, equal to 3n divided by 3, divide by 3 on the left hand side as well. This will cancel. 51 divided by 3 is equal to 17, is equal to n, which is the same as n is equal to 17. That means the term in the pattern that is equal to 3t5 minus 2 is term number 17. Therefore, that is T17, which is our final answer. Alright, now let us move on to 3.3. Consider this quadratic pattern of 5, 12, 29, 56, and 3.31 requires us to write down the next two terms of the pattern. So here we are told this is a quadratic pattern, and we have to subtract that from that, that from that, and that from that. See what we get, and then again we subtract to get a common difference. So what is 12 minus 5? That is 7. 29 minus 12, that is 17. 56 minus 29, that is 27. So now that we have the first difference, we have to find the second difference in order to get a common difference. So 17 minus 7. 17 minus 7, that is 10. 27 minus 17, that is 10 again. So now we know that this is really a quadratic pattern because we found a common difference on the second differences. But then we are required to write down the next two terms of the pattern. On the first differences, we know that from 27 to the next term we have to add 10. So what do we do? From here to that, which is the next term, we have to add 10. From that to the next term, we have to add 10 again. So what is 27 plus 10? That is 37. What is 37 plus 10? That is 47. So this is actually a pattern. What we know is that from 5 to 12, you have to add 7. From 12 to 29, you have to add 27. So this is the same thing that we will do here. From 56 to the next term, we have to add 37. From this term, we have to add 47 to get this term. So this is what we will do. 56 plus 37 is 93. So from 93 to the next term, we have to add 47. So 93 plus 47 is equal to 140. So now we have determined the next two terms of the pattern. That is 93 and 140. These are your answers. Now let us move on to 3.3.2. Alright, 3.3.2. Prove that the first differences of this pattern will always be odd. So the first thing we will do is determine the first differences. It's 12 minus 5, 29 minus 12, 56 minus 29. So we will have 12 minus 5, which is 7. 29 minus 12, that is 17. 56 minus 29, that is 27. So now we have the first differences. So the question requires us to prove that as the pattern continues, it will always give us odd terms. As we know that 7, 17, 27 are odd numbers. So we should prove that we will always get odd numbers as we continue with this pattern. So how do we prove that? We first have to determine the equation of the first differences. Now this is a pattern. Let us forget about this now. Let us focus on this pattern because this is what we want to prove. Now this is actually a linear pattern now, because if you find the differences with this, we get a common difference of 10, you see, because when you say 17 minus 7, that is 10, 27 minus 17, that is 10 again. That means now we have a linear sequence or a linear pattern. So here is what we will do. We will have to find the equation of this linear pattern. So what do we know? We know that our A is 7. A is equal to 7. D is equal to 10. So then what is our equation? Equation is determined by the general equation, which is Tn equal to a plus bracket n minus 1 times t. Now let us substitute. A is equal to 7 plus n minus 1 multiplied by d, which is 10. So now we will have 7 plus 10 times n, we have 10n, 10 times negative 1, that is minus 10. Oh, sorry, I forgot to put n here. 10n minus 10. Now let us sort this out. 7 minus 10, that is negative 3 plus 10n. So this is the equation of our sequence. This is the equation of our pattern, which is the equation of the first differences. So let me just rearrange the equation of the sequence. It is Tn equal to 10n minus 3. So it is still the same thing. So when we have this equation, this is where you explain that when you multiply 10 with any number, you get an even number. But when you subtract a 3, which is an odd number, from an even number, you will always get an odd number. Question 4.1. Consider the quadratic pattern. We have 3, 5, 8, 12. Determine the value of T26. So this is a quadratic pattern. On the previous question, we were also doing quadratic patterns. In fact, we're doing a quadratic pattern. So that means we have to find the first differences and the common difference, which is the second difference. Let us find the first differences and the second differences. So here is what we will do. 5 minus 3 is 2. 8 minus 5 is 3. 12 minus 8 is 4. So now we know the first differences, and let us find the second differences, which is the common difference. 3 minus 2, 3 minus 2 is 1. 4 minus 3, that is 1 as well. So this is really a quadratic pattern. If you don't get a common difference here, that means that is not a quadratic pattern. So now that we know the first and the second differences, let us determine the value of T26. And how will we determine the value of T26? T26 will have to be determined by the equation of this pattern. And right now we have to determine the equation of that pattern. What we know is the equation of a quadratic pattern is determined by a standard equation, which is Tn is equal to an squared plus bn plus c. So now we have to determine the values of a, b, and c. But in this case, a does not represent the first term. If you must, remember that with linear patterns, a represented the first term. But in this case, this a right here, does not represent the first term. So we need to determine what a is, what b is, and what c is. So we have 3 equations that help us determine a, b, and c. So Let us first use the equation that will help us get A. This equation is 2A is equal to the common difference, which is the second difference. Our common difference is actually 1. Then we have to solve for A. We divide by 2 here and divide by 2 here, which means our A is actually 1 over 2. So now we know the A. Then we have another equation that helps us get B. You have to memorize these equations. So the equation that helps us get B is 3A plus B is equal to the first term of the first differences. So the first term of the first differences. So all this is equal to 2. Now we know the value of A. Then we will have to substitute the value of A with 1 over 2 and then solve for B. So here's what we will do. 3 multiplied by A, that is 1 over 2, plus B is equal to 2. So let us sort this out. That is 3 over 2 plus B equal to 2. Let us take the 3 over 2 from the left hand side to the right hand side. We will subtract it here and subtract it on the other side, such that we will have B equal to 2 minus 3 over 2. What is 2 minus 3 over 2? Is equal to 1 over 2. We are left with C. And we also have one other equation, which is the last one, which helps us get the value of C. So that equation is A plus B plus C is equal to the first term of the sequence, the quadratic sequence, which is 3. So now we know the value of A and the value of B. We will substitute with the values. A is 1 over 2, B is 1 over 2 as well, plus C equal to 3. 1 over 2 plus 1 over 2, that is 1, plus C equal to 3. So in order to get the value of C, we'll subtract 1 here as well, such that C is equal to 2. So now we know the value of A, we know the value of B, we know the value of C, which means we can substitute on the standard equation now in order to get the equation of the quadratic pattern. That means Tn is equal to A, which is 1 over 2, 1 over 2 n squared, plus B, which is 1 over 2 times n, plus C, which is 2. This is the same as Tn is equal to 1 over 2 multiplied by n squared, that is n squared over 2, plus 1 times n, that is n over 2, plus 2. So this is the equation of the sequence, the quadratic sequence. But then we're not done. We are required to determine the value of T26, and we will use this equation to determine T26. So now it will be easier. So let us do that. Remember that our equation is Tn is equal to n squared over 2 plus n over 2 plus 3. So remember that our general equation is n is equal to n squared over 2 plus n over 2 plus 2. So now we have to determine T26. T26 is equal to 26 squared, because there is n, we have to substitute with 26 squared over n plus 26, n, which is, we substitute for n, 26 over 2 plus 2. Oh, sorry, this is actually 2, because we have a 2 here as well. So now that we have this, we can determine T26. T26 is equal to 26 squared is 676 over 2 plus 26 over 2 is 13 plus 2. So now T26 is equal to 676 divided by 2, that is 338 plus 13 plus 2, such that T26 is equal to 338 plus 13, that is 351 plus 2, that is 353. So now we know that T26 is equal to 353. And that is how we do quadratic patterns. Alright, let us continue to 4.2. A certain quadratic pattern has the following characteristics. T1 is equal to P, T2 is equal to 18, T4 is equal to 4 T1, or 4 multiplied by T1, T3 minus T2 is equal to 10. Let us actually write this down. T1 is equal to P, T2 is equal to 18, T4 is equal to 4 times T1, T3 minus T2 is equal to 10. So what we know is that T1, which is the first term, is P, and T2, which is term number 2, is 18, and T3, we're not told about T3. So this is T1, this is T2, and this is supposed to be T3, and we're supposed to have term number 4 here as well, but we don't know them. So these are the unknowns, and then we're required to find the value of P. We know that this is a quadratic pattern, and we were given that T3 minus T2, which means T3 minus T2, the answer is 10. So what options do we have now? the first differences. The first differences, we got one of them, which is 10. We were given here, that is T3 minus T2, which is equal to 10. So how do we get the other first difference? That is 18 minus P, which will be here, 18 minus P. By the way, let us go back to what we were given. We were given that T4 is equal to 4 multiplied by T1, and T1 is actually P. So that means we don't really have T4 as an unknown. It is an unknown, but that is known in a way, which is 4P, because it is 4T1, which means our T4 is actually 4P. And what else do we know? We know that T3 minus T2 is equal to 10, which means 18 plus 10 is equal to T3. So 18 plus 10 is equal to 28. So now we know the value of T3, that is 28. So that makes things much more simpler. Now we know that to get the final first difference, we have to subtract 28 from 4P, which is T4 minus T3, that is that and that, which is 4P minus 28. So now that we know the first differences, let us find the second differences, which are the common differences. So that is 10 minus 18 minus P. So 10 minus 18 minus P. And from here as well, we will subtract this 4P minus 28 minus 10. So what we know, this should give a common answer or the same answer. So therefore 10 minus 18, and this multiplied by this, that is plus P, is equal to 4P minus 28 minus 10, which is 10 minus 18 is equal to negative 8 plus P equal to 4P negative 28 minus 10, that is negative 38. So now let us take P to the other side. We'll subtract P here, subtract P here. So this cancels, and then we take the 38 to the negative 38 from the right hand side to the left hand side. We will add 38 here and add 38 here as well, such that negative 8 plus 38 is equal to 30. All this is equal to 4P minus P, that is 3P, and this cancels. So we divide by 3 here and divide by 3 here as well. This is equal to 1, such that P is equal to 30 divided by 3 is equal to 10. So the value of P is equal to 10, which is the same as P is equal to 10. So now we have determined the value of P. Alright, now we are done with the easy part of paper 1. It is just about time for us to move on to the more interesting stuff, where we will discuss graphs, parabolas and hyperbolas. I'm sure you don't want to miss that. And then we will do probability and financial mathematics. But before we do that, if you enjoyed this video, just make sure you press the subscribe button below to subscribe to the channel and hit the notification bell so that you will be notified when the next part of this video has been uploaded or any other video like this one has been uploaded too. And that marks the end of part A of the grade 11 paper 1 mathematics revision. See you on the next video.